Have you ever just looked up at the night sky and wondered, really wondered, how far back you can see? I don't just mean in miles, but in time. For basically all of human history, we've been asking that question. And now, we're getting answers that are, well, they're completely rewriting the story of the universe. Let's get into it.
It all starts with this one absolutely staggering number, 13.4 billion. That's how many years the light from this one particular object has been traveling through space just to reach our telescopes. We are quite literally looking at a ghost from the dawn of time itself.
And here it is. Meet JADES GS Z14-0. Now, thanks to the incredible James Webb Space Telescope, astronomers have officially confirmed it. And when they say confirmed, they mean they've analyzed its light, kind of like taking its fingerprint, to prove beyond a shadow of a doubt that is the most distant galaxy we have ever seen. We're seeing it as it was just 290 million years after the Big Bang. That's unbelievably early.
But wait a second, that brings up a really mind-bending question, doesn't it? How is it even possible to look at something and see it as it was billions of years ago? Well, it all comes down to the universal speed limit, the speed of light, and the fact that space itself isn't static.
So how in the world do you measure something that's billions of light years away? I mean, it's not like you can use a cosmic tape measure. You have to use the only thing that can actually cross that impossible distance, the light itself.
And the key to the whole thing is a concept called redshift. Here's the easiest way to think about it. Imagine the universe is a balloon that's being inflated. If you draw a wavy line on that balloon, as it expands, the wave itself stretches out, right? Well, light travels in waves, so as light from a galaxy travels towards us, the universe is expanding the whole time, stretching that light's wavelength. This stretching shifts the light towards the red part of the spectrum. For JADES GS Z14-0, it has a redshift of 14.32. That's a new record. And that number isn't just a score. It's a direct measurement of just how much our universe has grown since that ancient light first started its journey.
Okay, and here's where your brain might start to hurt a little, but it's super cool. While that light was traveling for 13.4 billion years to get to us, the galaxy itself didn't just sit still. The universe was expanding that entire time, carrying the galaxy farther and farther away from us. So if we could somehow magically pop over there right now, we'd find it's actually over 33 billion light years away from us today. It's just a wild illustration of how incredibly dynamic our universe really is.
But look, this story is about so much more than just breaking a distance record. What the James Webb Telescope found when it actually looked at this ancient galaxy, well, it sent absolute shockwaves through the entire astronomical community.
To put it bluntly, scientists were just stunned. Finding a galaxy this bright, this big, this early in the universe's life, it completely messes with all the existing theories about how things are supposed to work. In simple terms, a galaxy like this just shouldn't be there yet.
Let's just break that down for a second. The models, our best predictions, said that the very first galaxies would be, small, faint, kind of messy little things, just barely starting to pull themselves together. But what did we find in reality? We found JADES GS Z14-0. And it's not some tiny infant. It's a surprisingly bright and massive galaxy that showed up to the party way, way ahead of schedule.
So what does this all mean? The implications here are staggering. This isn't just some minor adjustment to the textbooks. This suggests that the whole assembly line for building galaxies and making stars kicked into high gear way earlier and way faster than we ever thought possible. It basically means the first chapter of the universe's story needs a serious rewrite.
So, to really appreciate the scale of what we're talking about here, let's actually place this discovery on the grand timeline of the cosmos.
Okay, so you have the Big Bang, 13.8 billion years ago. After that, there was a long period called the Cosmic Dark Ages. No stars, no galaxies, just darkness. But then, only 290 million years later, which is like the blink of an eye in cosmic time, JADES GS Z14-0 appears, one of the very first lights to switch on in that vast darkness. For perspective, our own galaxy, the Milky Way, didn't really start forming until hundreds of millions of years after the era we're seeing this new galaxy in. It's just incredible.
Ultimately, pointing a telescope at the deepest, darkest parts of space isn't just about collecting data or breaking records. It's about a much more fundamental human quest, the search for where we came from.
And that's really why this matters so much. Every discovery like this one is another piece of our own cosmic puzzle. I mean, we're literally made of stuff that was forged inside stars, within galaxies. By seeing the very first ones come into being, we're getting a direct look into the crucible that eventually created everything we see, including ourselves. We're looking at our own origin story.
So we're left with this thought. This one single galaxy has already upended our understanding of the early universe. It forces us to ask, if we were this wrong about how quickly everything got started, what other incredible surprises are just waiting for us out there in the dark? The James Webb Telescope is really just getting warmed up, and it sure seems like the universe has a lot more secrets it's ready to tell.